Okay, now we're going to go over how to simplify these radicals by hand. This is something that on your test you are going to be required to do. Sometimes I won't say that you have to, as far as, you know, you can use your calculator, but sometimes I will say that you do have to simplify these by hand. So this is something that we will have to do by hand on your test. Not super difficult. Okay, it pulls from some stuff that you guys did in middle school as far as coming up with your prime factorizations. But here we go. So I have the square root of 360, and I want to simplify this square root by hand. Well, in the magical land of numbers, there are things that are called radical trolls. Okay, so this right here is an example of a radical troll. Looks kind of similar to Coach Wiederholt. But we don't need to let him know that. But essentially what radical trolls try to do is they try to trap these numbers within their cave. Okay? Now, radical trolls, however, are reasonable people. So they are willing to let groups out of their cave, and the group is dependent on what the index is. So for this one here, I'm looking at a square root, and even though they don't write it, the square root for this would be 2. Okay? Square root has an index of 2. So essentially what's going to happen is this radical troll will let any group of 2 out. But the catch is the groups of 2 have to be identical pairs. Okay? So you guys see all these numbers that are trapped up here in this radical cave. Well, where do those numbers come from? Well, if I look at the square root of 360 and I break 360 down by its prime factors, I could split up 360 to 2 and 180. I could split up 180 into 2 and 90. 3 and 30, 3 and 10, and 2 and 5. So you can see, here's our 5. We have 2 3s that are right back here, and we have 3 2s. So where did these numbers that are trapped in the cave come from? Well, they came from this 360 here breaking down into its prime factors. So the way that this will work is pairs can get out. So this pair of 2s can get out. And this pair of 3s can get out. But the 2 and the 5 are stuck inside of the cave forever. So it's kind of a sad story, but such is life. Okay? So essentially what happens is the 2 and the 3s make it out. They're on the outside. But the 2 and the 5 do not, and they are stuck on the inside. Okay? So the square root of 360 simplifies down to a 2 times 3 on the outside, which we know is 6. And a 2 times 5 on the inside, which we know is 10. So we can simplify the square root of 360 to 6 square roots of 10. Now, when you guys do these problems, you are not going to need to draw a cave and radical troll every single time, but it is helpful to help you guys simplify these down. So here we have the square root of 250, 25 and 10. 2 and 5. When I'm dividing these, I only want to pick prime numbers. So prime numbers are 2, 3, 5, 7. 9 is not a prime number. 11 would be the next prime number. So we're just kind of breaking them down in that pattern there. 10 is 2 and 5. 25, whoops, change colors, my bad. 25 is 5 and 5. Okay. Now, when I'm looking at this here, am I looking for pairs? And the answer is yes. This is a square root, which means that the index of that is 2. So I'm looking for pairs. So do you guys see any pairs up here? Well, yes, I see a pair of 5s. So that means that for the square root of 250, there is a 5 on the outside. And what is left on the inside? A 2 times a 5. Okay? So the square root of 250 simplifies down to 5 square roots of 10. Well, how would that change if I asked you to find the cubed root of 250? The cubed root of 250. Well, we break it down the exact same way. 25 and 10, 5 and 5, 2 and 5. But now I am asking for the cubed root, which means that I do not need groups of 2, I need groups of 3. So do we have any triples here? Well, I've got a 5. I got 3 5s. Okay, I'm going to do that in green. I'm sorry. Now it's looking like Christmas. Okay, so there is a 5 that is on the outside of the root. And what is left on the inside? Well, there's a 2 that is left all on its own. So the cubed root of 250 can simplify down to 5 cubed roots of 2. 5 cubed roots of 2. So this number out in front here, whether it's a square root, whether it's a cubed root, tells you how you are looking for the groups. Okay, if I had a 5th root, I would be looking for a group of 5 in order to be able to get out. So I want you guys to practice these two on your own. You've got the square root of 75,600 and you have the 4th root of 75,600. So you're only going to have to do one prime factorization here, do the one prime factorization, then copy it down for the other one. But then pay attention to what kind of groups you are looking for. Okay, hopefully you've paused the videos so you can go over these. The easiest one for me to see is 756 and 100. And then when we go to 756, that's a big number that I don't really know the factors to. So I usually look at the fact that it's even, which tells me that I'm going to have a 2. And that splits it up with 378. And again, guys, I'm just using my calculator. Again, 378 is also even, so I know I can divide that by 2. And that gives me 2 and 189. 189. Excuse me. 189 is not even, so it's not going to be divisible by 2. So I could try 3. And I'm just picking the next biggest number, so that'd be 3 and 63. Okay, 3 and 63. Some of you guys might look at that and say, oh, 9 and 7, but some of you guys might not, and that's fine if you don't. 3 and 63, you could say would be dividing by 3 again, because it's not going to be divided by 2. Oh, yep, that works. Gives me 3 and 21. And then 21 would be 3 and 7. Okay, and then along with that, we've got 100. Can break it up however you want. 2 and 50. 50 is 2 and 25. 25 is 5 and 5. So this first one, I have a square root. So square root means I'm looking for groups of 2. Square root means I'm looking for groups of 2. So I see a pair of 2's. That's on the outside. I see another pair of 2's. That's on the outside. I see a pair of 3's. That's on the outside. I see a pair of 5's. That's on the outside. So all of those pairs were able to escape that mean old radical troll. Oh, crap. Frick. Sorry, guys. Man, I suck. So we had a 2, we had a 2, we had a 5, and we had a 3. Okay, and then what is left on the inside of this problem? Well, I still have one singular 3, and I have one singular 7. So the final answer for the square root of 756,000 is 2 times 2 times 5 times 3 all on the outside. So 2 times 2 is 4, times 5 is 20, times 3 would be 60. And then on the inside, I have a 3 times 7, which is 21. So the square root of 75,600 is 60 square roots of 21. Okay? Now, For the fourth root, we do the exact same breakdown on this. Okay, so 756, 100. I'm going to change colors so we can see it a little easier. 756 and 100. 2 and 378. 2 and 189. 3 and 63. I'll show you guys. You could have also done 9 and 7, which would have then given you 3 and 3. Okay, and then up top, 100, you could have gone 10 and 10. That still would have been right. 2 and 5. 2 and 5. Okay, so there's our breakdown there. So what are we looking for in our groups on this one? Well, we are looking for a group of 4. Looking for a group of 4. Okay, so I've got 1, 2, 3, 4. So there are 4 2s. All right. So we have 4 2s. So there's a 2 on the outside. Are there any other groups of 4? Well, I've got 1, 2, 3 3s, but I don't have any more 3s. I've got 2 5s, no more 5s. I've got 1 7. So 2 is the only group of 4 that is able to escape. What am I left with on the inside? Well, I've got 3, 3, 3. So 3 3s being multiplied together. I've got a 7. I've got a 5. And I've got a 5. So all of those numbers are stuck on the inside. Okay? And I forgot to add my fourth root there. So my answer for this is 2. And then it is the fourth root of, and I don't know that, so 3 times 3 times 3 times 7 times 5 times 5 is 25, which would be 4,725. So 2 fourth roots of 4,725. Okay, so that's kind of going through how to simplify these things by hand. And we'll practice that more next class time.